A spatial database, or geodatabase, is a database that is optimized to store and query data that represents objects defined in a geometric space. Most spatial databases allow representing simple geometric objects such as points, lines and polygons. Some spatial databases handle more complex structures such as 3D objects, topological coverages, linear networks, and TINs. While typical databases are designed to manage various numeric and character types of data, additional functionality needs to be added for databases to process spatial data types efficiently. These are typically called geometry or feature. The Open Geospatial Consortium created the Simple Features specification and set standards for adding spatial functionality to database systems. Features of spatial databases. Database systems use indexes to quickly look up values, and the way that most databases index data is not optimal for spatial queries. Instead, spatial databases use a spatial index to speed up database operations. In addition to typical SQL queries such as select statements, spatial databases can perform a wide variety of spatial operations. The following operations and many more are specified by the Open Geospatial Consortium standard: spatial measurements, computes line length, polygon area, the distance between geometries, etc. Spatial functions modify existing features to create new ones, for example by providing a buffer around them, intersecting features, etc. Spatial predicates allows true-false queries about spatial relationships between geometries. Examples include: do two polygons overlap, or is there a residence located within a mile of the area we are planning to build the landfill? Geometry constructors creates new geometries, usually by specifying the vertices which define the shape. Observer functions queries which return specific information about a feature such as the location of the center of a circle. Some databases support only simplified or modified sets of these operations, especially in cases of NoSQL systems like MongoDB and Couchdb. Spatial Index. Spatial indices are used by spatial databases to optimize spatial queries. Conventional index types do not efficiently handle spatial queries such as how far two points differ, or whether points fall within a spatial area of interest. Common spatial index methods include grid, z-order, quadtree, octree, UB-tree, arc-tree, typically the preferred method for indexing spatial data. Objects are grouped using the minimum bounding rectangle. Objects are added to an embryo within the index that will lead to the smallest increase in its size. R plus tree, R tree, Hilbert tree, X tree, KD tree, M tree, and M tree index can be used for the efficient resolution of similarity queries on complex objects as compared using an arbitrary metric. Point access method, binary space partitioning, subdividing space by hyperplanes. Spatial database systems. List equals, all OpenGIS specifications compliant products, open source spatial databases and APIs, some of which are OpenGIS compliant. Boeing's Spatial Queries Server spatially enables Sybase ASE. Small World VMDS, the native GE Small World GIS database. Spatialite extends SQLite with spatial data types, functions, and utilities. IBM Db2 Spatial Extender can be used to enable any edition of Db2, including the free Db2 Express C, with support for spatial types. ClusterPoint offers native indexed support for distances, range matching and polygon matching as well as aggregation. Oracle Spatial, Microsoft SQL Server has support for spatial types since version 2008. PostgreSQL DBMS uses the spatial extension PostGIS to implement the standardized data type geometry and corresponding functions. Teradata Geospatial includes 2D spatial functionality, OGC compliant, in its data warehouse system. MonadB GIS extension for MonadB adds OGS simple features to the relational columns store database. Linto SQL Server supports spatial types and spatial functions according to the OpenGIS specifications. MySQL DBMS implements the data type geometry plus some spatial functions that have been implemented according to the OpenGIS specifications. However, in MySQL version 5.5 and earlier, functions that test spatial relationships are limited to working with minimum bounding rectangles rather than the actual geometries. MySQL versions earlier than 5.0.16 only supported spatial data in MyISAM tables. As of MySQL 5.0.16, INNODB, ANDB, BDB, and Archive also support spatial features. Neo4j, graph database that can build 1D and 2D indexes as BTREE, Quadtree and Hilbert curve directly in the graph. Allegro Graph, a graph database, provides a novel mechanism for efficient storage and retrieval of two-dimensional geospatial coordinates for resource description framework data. It includes an extensions syntax for SPARQL queries. MongoDB, RavenDB, and RethinkDB support geospatial indexes in 2D. Esri has a number of both single-user and multi-user geodatabases. Spacebase is a real-time spatial database. Couchdb, a document-based database system that can be spatially enabled by a plugin called GeoCouch. Couchdb is a cloud-based geospatial database on top of PostgreSQL with PostGIS. StormDB is an upcoming cloud-based database on top of PostgreSQL with geospatial capabilities. DB is an open-source big data management system with native geospatial capabilities. SpatialDB by MinerP is the world's first open-standard spatial database with spatial type extensions for the mining industry. H2 supports geometry types and spatial indices as a version 1.3.173. An extension called H2GIS available on Maven Central gives full OGC simple features support. GeoMesa is a cloud-based spatio-temporal database built on top of Apache Accumulo and Apache Hadoop. GeoMesa supports full OGC simple features support and a GeoServer plugin. Angra 10s and 10.2 include native comprehensive spatial support. Angra includes the Geospatial Data Abstraction Library cross-platform spatial data translator. Tarantool supports geospatial queries with RTREE index. SAP HANA supports geospatial with SPS08, 1. Table of free systems especially for spatial data processing equals. See also, object-based spatial database, spatio-temporal database, spatial query, spatial analysis, geographic information system, location intelligence. References. Further reading, Spatial Databases, Atur, Shashi Shkla and Sanjay Chawla, Prentice Hall, 2003, ESRI Press. ESRI Press titles include Modeling Our World, the ESRI Guide to Geodatabase Design, and Designing Geodatabases, Case Studies and GIS Data Modeling, 2005 Ben Franklin Award winner, PMA, the Independent Book Publishers Association. Spatial Databases, with Application to GIS Philippe Rigor, Michel Skull and Agnes Voizard. Morgan Kaufman Publishers 2002, Evaluation of Data Management Systems for Geospatial Big Data Pouria Mirian, Anaid Bajari and Adam Winstanley. Springer. 2014. External links, An Introduction to PostgreSQL PostGIS, PostgreSQL PostGIS as Components in a Service-Oriented Architecture SOAA Trigger-Based Security Alarming Scheme for Moving Objects on Road Networks Sajaiman Abraham, P. Sojan Lal, published by Springer Berlin/Heidelberg 2008. Geodatabase ArcGIS Resource Center Description of a geodatabase,